Hey everyone, welcome back. We have been exploring eigenvalues and eigenvectors, and today we are tackling a special case, repeated eigenvalues in a 2x2 matrix. This can lead to interesting situations, so let's dive in. Just a quick reminder, eigenvalues are the values that satisfy the equation A times V is equal to lambda times V, and eigenvectors are the corresponding vectors. We find eigenvalues by solving the characteristic equation given by determinant of A minus lambda I is equal to 0. Sometimes when we solve the characteristic equation for a 2x2 matrix, we get the same eigenvalue twice. This is called a repeated eigenvalue. Let's see how this affects finding eigenvectors. Let's take the matrix A is equal to 3, 1, negative 1 and 1. Let's find its eigenvalues. To begin, we will solve the characteristic equation given by determinant of A minus lambda I equal to 0, which we have 3 minus lambda, 1, negative 1 and 1 minus lambda. Determinant of this is equal to 0. On simplifying the determinant, we get 3 minus lambda times 1 minus lambda plus 1 is equal to 0. 3 minus 3 lambda minus lambda plus lambda square plus 1 is equal to 0. Lambda square minus 4 lambda plus 4 is equal to 0. On the left we have lambda minus 2 whole square is equal to 0. And on solving this, we get the eigenvalues as 2 and 2. It can be seen that A has a repeated eigenvalue which is 2. Now let's find the eigenvectors. We will use the equation A minus lambda I into V is equal to 0, where A is the given matrix and lambda is equal to 2. On substituting lambda equal to 2 in the above equation, we get 3 minus 2, 1, negative 1 and 1 minus 2 into V, which is x1, x2 is equal to 0, which is the column vector 0, 0. That is 1, 1, negative 1 into x1, x2 is equal to 0, 0. On R2 we perform R2 changes to R2 plus R1. This gives us first row unchanged and the second row becomes 0, 0, and here we have x1, x2 is equal to 0, 0. Therefore we get x1 plus x2 is equal to 0, which gives us x2 is equal to negative x1. Thus, we have only one linearly independent eigenvector, which is V is equal to x1, minus x1, where x1 is a real number. If you keep x1 as 1, then we get V is equal to 1, negative 1. This means that for a 2x2 matrix with a repeated eigenvalue, we might not be able to find two linearly independent eigenvectors. This has implications for how we might simplify the matrix using diagonalization. Which we'll explore in future videos. For now, it's important to understand that in this case we can still find one eigenvector and understand how the matrix transforms vectors in that direction. Hopefully, you now have a better understanding of repeated eigenvalues. Do you have any questions, examples, or suggestions you'd like to share? Leave them in the comments below. And if you enjoyed the video, please like and subscribe. See you in the next one. Till then, happy learning.